to repost it in case anybody's coming in new. While you come in, if you want to just let us know where you're here from, we'd like to see where everybody's at. Where are you coming from? Where are you joining us from today? I'm in the Dallas office, and our speakers are in lovely, warm Arizona. I see Kentucky. I see South Carolina. We are excited to have you here for our TI Talk. Oh, not South Carolina. Sorry, I saw Georgia. I apologize. I'm going to give everybody just another minute or two as they come in. Kentucky, Texas, Georgia is represented. Again, my name is Parisa Schulte. We are happy to have you here for our TI Talks today. Go ahead in the chat and tell us where you're here from as we give everybody just a few minutes to come on in to the WebEx. You'll be able to find the chat option down at the bottom of your screen, the 3 little dots that say more options. We have lots of Texas people here. Excellent. Hi, everybody. Welcome to our TI Talk series. My name is Parisa Schulte. I will be your host and moderator today. We are excited to get started in just a couple minutes. We're waiting to give everybody a few seconds to come in, get used to the WebEx platform. While you're coming in, if you can let us know where you're joining us from, so we know how many people are here from all over the country, that would be great. You can do that in the chat option. So if you can just chat to chat to everybody and all the attendees and let us know where are you joining us from today. San Antonio, Dallas, Irving, excellent. So Georgia, Kentucky are probably our furthest. Richard, I'm not sure where Washington High School is because there's a lot, I'm sure there's a lot of Washington high schools. But thank you everyone for joining us. So I'm going to go over just a couple logistical things for us before we get started. As the presentation is going on, if you have any questions, if you can put them in the chat, there'll be an opportunity to post those to our presenters, and I will copy and paste them and keep track of them to make sure they hear them and answer them during those scheduled breaks. So we're going to go ahead and get started here. My name is Parisa Schulte. I am an education technology consultant for Texas Instruments. I cover about half of Texas, Arizona, and New Mexico. I'm a former middle school math teacher and educator and a former national instructor for TI. I've had the opportunity and joy of working with our 3 presenters today as I support Arizona, and I'm very excited for them to share with you the amazing initiatives that they have created to help empower and encourage students in Arizona to become engineers and take that pathway and help them successfully along that pathway. So we are going to hear from Ganesh, Robin, and Jennifer in just a second, but I'm going to share the agenda with you so you know kind of what to expect for today. Everybody should be getting in. We're doing some introductions, and then we will hear from our speakers in just a couple minutes. There will be 3 options or 3 times for question and answer throughout. So again, if you didn't hear me earlier, if you can put your questions in the chat window, I will make sure that they see those questions and hear those questions and answer them at the designated times. And then I'll share a few more things with you about how TI can support any initiatives like this that you're interested in doing, and we'll have one more opportunity for question and answer at the end. So again, please feel free to put those in the chat. We look forward to hearing your questions. I know our presenters look forward to hearing your questions, and we just thank you for being here with us today. So we are going to go ahead and hand it over to our wonderful presenters and get started here.
Good morning, everybody. Welcome to Engineers from Day One from Arizona State University, Tempe. My colleagues and I will be sharing about this National Science Foundation funded project, which started in 2017 officially, but with legwork in 2016 with collaborators, including Texas Instruments. So we're grateful for Texas Instruments for being a wonderful partner. Our presenters today with me are Jennifer Velez and Robin Hammond, and I will let them introduce themselves first. Jennifer, go ahead.
Good morning. My name is Jennifer Velez. I'm a former teacher, now working for the Fulton Schools of Engineering in Fulton Outreach and Recruitment. So my focus since 2013 has been on K-12 students, families, and K-12 teachers.
Robin.
Hi, I'm the founding director of the Fulton Schools of the Engineering Career Center at Arizona State University. We are the largest engineering college in the country with over 25,000 engineering students and aspiring engineers and technical professionals. I have a dream job. It's really great to help engineers who help improve the quality of life for other people in the world. And it's our pleasure to talk with you today about some of the ways we help inspire some of those ideas.
Thank you, Jennifer and Robin. My students call me Dr. G, but I go by Ganesh, and I'm at Arizona State University's Fulton Schools of Engineering. I'm a faculty member here. I'm also a Tucker professor for engineering education and assistant dean for engineering education. The Tucker professorship was established by the former CEO of Motorola, Gary Tucker, and his spouse, Diane Tucker. And that has helped us actually initiate many of the projects that you will hear about today before we sought official funding from the National Science Foundation. So I wanted to acknowledge their contributions, which has made all of this possible. The project is funded by the National Science Foundation's Includes program. And this is an early pilot program to launch an alliance of collaborators who can come together around a shared goal and work towards achieving that goal. And before we get into more details about the project, I wanted to share a little bit about the charter. This charter is the foundation for all of the work that we do. And we take pride in how we measure our success. And our success is measured based on who is included in our enterprise, education enterprise and education pathways, rather than who's excluded. So we do a lot of work to make sure that anybody who wants an opportunity to succeed in any of the professions that they would like to pursue, for which they can go to college at ASU, we offer them the opportunity to do so. And that's an interesting way of looking at things, rather than saying we are a very selective institution that only admits 20% of its applications. We don't do that. So that's what's different about us. Another sort of key global indicator is that the speed of technology-induced skill displacement is projected to double over the next 10 years. And as a result, more than 30% of US workers will need to change jobs or upgrade their skills significantly by 2030. And 65% of today's primary school children who are in school will hold jobs that do not exist today when they graduate from college. And that's a challenge. So there are two very important reports McKinsey Global Institute published, one in 2015 called The Digital America, A Tale of the Haves and the Have-Mores, and one in 2017 called Jobs Lost, Jobs Gained, Workforce Transitions in a Time of Automation. And it might be worthwhile to pursue those, because those reports set the tone for the challenges that a global workforce will need to attend to. And with that in mind, we want to broaden participation in engineering. And our goal is to create pathways to engineering for traditionally underrepresented populations. And in engineering, that is defined as Hispanics and Latinos, African American and Native American or American Indian students, and Native Hawaiian or Pacific Islander students. First generation students are first in their family to go to college and earn a 4-year college degree. Neither of their parents have earned a 4-year degree. And women and those with socioeconomic need. These populations typically are severely underrepresented in engineering. So our goal was to find ways to increase their participation in the engineering innovation enterprise by making it possible for them to enter engineering and then persist in engineering. So one of the barriers to first generation students and others who may not have traditionally thought of becoming an engineer is that they don't get to see others like them doing engineering, which makes them assume that such roles are close to them and therefore they don't pursue this pathway. Oftentimes, if there are people in their neighborhood who become engineers, they end up leaving that neighborhood to go work somewhere else. And as a result, they do not have the opportunity to sort of interact with their neighbors or others in the community who might be engineers, who might guide them, who might inform them about the opportunities that exist for them for future possible careers. And that's one of the reasons why we want to leverage the benefits of diversity, because we want these populations to not just be merely consumers of technology and the engineering innovation products, but we want them to also design them and be enablers of new technologies and new processes and new products. And that's one of the key goals of broadening participation that is advanced by the National Science Foundation's funding, regardless of whether it's the Includes project or any funding that's provided by the NSF. They expect a broadening participation effort in their work. So our alliance is called a Collective Impact Alliance, with the idea that each institution can make small changes that can have a collective impact on a common agenda. So we chose to work with area school districts. Some are high school districts, some are comprehensive districts that serve K through 12. The Maricopa Community Colleges, which is the largest community college system in Arizona, and several industry partners like Honeywell, Intel, Texas Instruments, and a local foundation called the Helios Foundation. So our common agenda is to enhance entry and persistence in engineering of our targeted populations. And we have a theoretical framework, which is based on a simple acronym, AEIOU, with each one of these, awareness, enjoyment, interest, opinion formation, and understanding of engineering being very important to help students navigate their choice of major. So if you are aware of what engineering is and who engineers are and what they look like, you can confront the social stereotypes that exist that may make you feel like, oh, I'm a woman, I don't think I belong in engineering. Oh, I'm a Latino or I'm an African American, I don't belong in engineering. So we want to increase awareness of what engineers do and who engineers are and change any negative stereotypes that might exist. Enjoyment. We want students to enjoy doing engineering so they can figure out why engineering is socially relevant. We want them to have interest in it because that's how they begin to develop their own identity as a potential future engineer. We want them to have opinions about what engineering can do for them and their communities and neighborhoods so they can envision their future selves as engineers and make social change and impact their community. And lastly, if they have all of this and their understanding of engineering and what engineering can do for themselves and for society, they might make the choice of wanting to become an engineer and join an engineering program. So this is sort of our broad thinking about why we want to do our work. So this was sort of established in 2016 to help us frame our work and make sure that we are paying attention to students' learning experiences. So we start with awareness about engineering and its social relevance, that it will lead to enjoyment that could engender a deep interest, and this interest will lead to opinion formation, and opinion formation will lead to understanding, which will result in purposeful choices to pursue engineering pathways. And the goal is to have the Collective Impact Alliance is to have improved coordination between one of the largest comprehensive research public universities in the country. We have over 100,000 students at ASU, and select K-12 feeder systems because this is a pilot. Now that the pilot is concluding, we are thinking about how to expand this work to the state of Arizona. And time for questions.
Okay, Ganesh, we got one question from Richard Howard. He wanted to know, can he find the reports on the web that you referenced in the beginning? When you were talking about 65% of jobs don't exist at this time?
Yes. So the McKinsey Institute publishes all of their reports and they're available as PDFs online. So if you just search for the McKinsey reports, you'll find them.
And that's MACKENZIE?
Just MCKINSEY.
Okay, perfect. That was our only question so far.
Okay.
Does anybody else have any questions for Ganesh or Jennifer or Robin before they move on? Let's give everybody just a second to figure out where the chat is.
Right.
So another question we have is, are there any representatives of industry that have experiences like this? So why do you choose these districts or these partners in particular?
Very good question. So when we spoke with Helios Foundation, there is a vice president in that institution who is a native Arizonan who grew up in Tempe, who knows the community, who knows the place. One of the key things that we were told by this individual, his name is Vince, was that we should go to the places where we can make the biggest difference. So we chose Tolleson School District, which is a high school district for that reason. They're a minority majority district. We chose Tempe Union High School District, which is also a hometown district because they are in our neighborhood and many of their students come to us. And we chose Chandler, which is sort of a suburban type of school district. And Tolleson and Phoenix Union are both urban, high poverty, serve a large population of high poverty neighborhoods. They are unique in their population that attends their schools. They're a minority majority district. So we chose them deliberately for that reason. And Texas Instruments and Intel and Honeywell employ many of our graduates. And we worked with the representatives who at that time were connected with our career center that Robin directs. And we reached out to them and they connected us to other people. For instance, at Texas Instruments, it was Eric Patton. And we ended up chatting with each person individually. And then collectively, we came up with this idea for working together. So not only are they future employers of our graduates, they also work heavily in offering experiences, learning experiences for our students during the undergraduate program. And Texas Instruments in particular has also helped us with curriculum and materials that you will find out in our presentation later today for our K-12 programming. Does that answer the question?
Yes, thank you, Ganesh. And thank you. I believe Richard put the link in the chat for
Awesome.
everybody. So I'll go ahead and share that, Richard, so that all attendees can see it. Thank you.
Perfect. Thank you very much. There are no more questions. I'll hand it over to Jennifer Velez, who will talk about our strategies to enhance entry into engineering.
Great, thank you. Yeah, so as Ganesh mentioned, our framework is around, awareness and interest and enjoyment more so in the K-12 populations. And as they get older, we would hope that they would kind of move along that spectrum towards opinion formation and understanding. So let's talk about strategies then. How do we get them to those different components of the spectrum? My slide advancer. Well, we really focus in our unit, K-12 outreach, on designing and implementing learning experiences for K-12 students, for their families, and for teachers. So let's talk about some of the specific strategies that we use to do that. So first and foremost, we go to meet the students where they are. So as Dr. Ganesh mentioned, we really want to bring in broaden participation, bring in more underrepresented students in STEM. How do we go about that? Typically, if we open up an opportunity to the public, we sort of see the usual suspects taking advantage of those opportunities. Maybe they already have parents in STEM fields. Maybe they already have parents who have attended a university. They already know where to look for those opportunities. They know how to seek them out. And they already have an affinity oftentimes towards STEM careers. So how do we bring these opportunities to students who don't have those advantages? So we are strategic about who we partner with. Ganesh mentioned Title I school districts, districts that are minority majority districts. We seek out specific schools and districts to bring in their students to participate in the opportunities that we provide, whether that's a specific program or a camp or an event. So we try to do some targeted recruitment to those schools specifically and seek out partnerships with those schools and those communities. We also partner with organizations like Girl Scouts and Boys and Girls Clubs. We look for those organizations in those communities to bring in more underrepresented populations. Girl Scouts is a group that we have a relationship that continues to grow. And we hope that through those partnerships, we can particularly increase participation amongst girls. And then Ganesh mentioned Tolleson School District, Phoenix School District. We also partner with migrant programs in Mesa for our summer camps and compensatory education programs for summer experiences. So, leveraging those kinds of opportunities in the partners who we work with. Another strategy, Ganesh also mentioned the importance of seeing yourself in those who are engineers or pursuing engineering. So we enlist the support of what we call near-peer engineering mentors. So young people, usually undergraduate students, sometimes graduate students, who are in engineering and from diverse backgrounds. So young women, underrepresented populations in STEM, and get them working with our K-12 students. This not only provides an exchange of information where our mentors can talk to them about, here's what you got to do to get into college. Here's how you get access to scholarships. Here's how you navigate FAFSA, which is a huge concern oftentimes because that thing can be very intimidating. But it also gives our young participants the opportunity to hear stories from our engineering mentors about the challenges they had to overcome. It normalizes failure. We encourage our mentors to talk about a time that they failed and how they were able to bring themselves back up and recover. And that kind of, we hope, demystifies the college experience. It demystifies engineering to some respect, and it normalizes kind of the rigor of an engineering program and lets students know that you're going to fail and that's okay. You still belong here. Of course, it helps them envision themselves as a future possible engineer when they see someone else who looks like them pursuing engineering. It's a really key component to our programs. And then in addition, of course, giving them plenty of opportunities to visit a college campus. This might be through a residential program, or it could be through tours or field trip events. We find this particularly critical to our first generation college students, those whose parents never pursued or completed a college degree program. These students are oftentimes unfamiliar with what a college campus is like, with what the college experience is like. And so giving them an opportunity to immerse themselves in a residence hall community, to walk around campus, to see labs, to see students working, hanging out in the Memorial Union or our student union. It really gets them feeling like they are a part of a campus community. They get to again, envision themselves one day living here, attending school here. So giving them that that chance to be on campus, feel like a student, and to again pull back that veil and demystify what college is like for those students. So key piece to our programs is getting them physically on campus. It's been hard during COVID, but we are really excited to get them back on campus as soon as we can. We also train teachers. As I mentioned, I am a former teacher. I love every opportunity I can get to work with my peeps, with K-12 teachers. We really do believe that teachers play a critical role in fostering young minds and instilling in them engineering habits of mind. So engineering habits of mind are things like collaboration, communication, creativity, systems thinking. Those are skills that not only are used daily by engineers, but those are skills that are going to benefit any learner. So we find that teachers buy into the workshops that we offer, the training opportunities that we provide, simply because they know this is of value to their students, and they're always looking for ways to nurture and foster those practices in their classroom. So we talk to them about, here's how you can do an engineering design challenge, and here's how deep you can take it, and here's how simple you can make it. Here are the things that are quick wins that will teach them about normalizing failure, comfort with failure. It'll teach kids about design thinking. So we are always looking for opportunities to interact with teachers and provide them with opportunities to incorporate engineering into their classroom, but also just how to build those skill sets so that those students are really engaged in learning and improving themselves as students. And then, of course, plenty of opportunities to do engineering. We strive to mimic what engineers do in the real world as closely as possible with the young people who we work with. And that includes getting technology into their hands. Dr. Ganesh mentioned, we want to increase their comfort level with technology to the point where they might someday become developers of that technology. We know that we are all consumers of technology, but very few of us are developers of that technology. So how do we broaden participation in that realm so that these young people become courageous and willing to pursue that pathway? Well, let's get them in, let's get some great tech into their hands. Here we have some students who participated in our summer academy back in 2019. We used TI's STEM kit. Specifically, this is the pet car alarm, where they used a TI calculator to program sensors that could detect temperature in a hot vehicle. So these girls are in the midst of testing out what they've created. We also use technology such as VR. We recently did a series of workshops with Girl Scouts where they got to use Google Cardboard headsets and create a virtual realm to envision the future of sustainable transportation. We try to put Arduinos in their hands. We love to give them microcontrollers. We do Python workshops to get kids coding. We've also used, of course, Lego robotics, which I'll talk about in a little bit, but we found that the EV3 robots are really handy for teaching mechanics, for teaching, gear ratios, for teaching, rudimentary programming, and all kinds of cool stuff. So we like to put a lot of different kinds of technology into the students' hands, again, for the purpose of really just increasing that comfort level with technology. There are a lot of other ways that we give opportunities to do engineering, and on the subsequent slides, we'll talk about those. So Young Engineers Invent, I just mentioned, is a series of workshops currently around sustainable transportation and VR. So we work specifically with students this past year at Hope Academy, which is an alternative school run out of the Maricopa Regional School District for students who don't thrive in the typical traditional classroom. So we actually were able to push into their classroom virtually and deliver workshops on sustainability, transportation, and VR. And then we did a similar series for Girl Scouts that just wrapped up a couple of weeks ago. So that's one of our programs that's really targeted towards first generation and underrepresented students. And it's kind of framed as an engineering design challenge. So presenting them with the challenge and then using the technology that we've provided them to address that challenge. First Lego League. FIRST stands for Inspiration and Recognition of Science and Technology. It's a global nonprofit. Arizona State University is the statewide partner for First Lego League Junior and First Lego League. So we run and oversee all of the tournaments available to these students. If you have never been to a First Lego League event, please Google it. It is amazing and fantastic. We love this program because it's so exciting and so fun to see the kids get so excited about their robots, and also because the program gives an opportunity for the students to do a research project about a real world problem. And then it also teaches something called core values, things like teamwork, collaboration, things that are really at the core of being a good citizen. So it's a really well-rounded program. And I highly recommend that you check it out. The spectrum or the family of FIRST programs includes First Lego League Junior for the little ones, First Lego League for kind of that upper elementary, middle school, and then there's also FTC, First Tech Challenge, and First Robotics Competition, where the robots get progressively bigger and bigger and more complicated. So, and again, the events are meant to mimic the celebratory atmosphere of a sporting event, and it is very much true. So definitely check those out if you can.
And we hold the state competition at a big indoor stadium.
Yes, and it is a sight to behold.
All right, next slide.
Engineering Projects and Community Service is one of those programs that we offer in school. We train teachers in the summer for 1 week to facilitate the program in their classrooms. So we've got teachers who are physics teachers, math teachers, engineering teachers, AP research, AP environmental science. So we've got a broad spectrum of teachers. We've got STEM capstone teachers, STEM service learning programs, all incorporated into a school day at roughly 30 middle schools and high schools around the Phoenix area. The program was actually started at Purdue University for undergraduate students. We adopted that undergraduate program, I don't know, early 2000s, I think, for our undergraduate students. And the idea is, how do we get students doing engineering while really paying close attention to who it is that you're engineering these solutions for? So really taking into consideration who is going to be using the technology, who's affected by the technology or the innovation, and how do you ensure that their input and feedback is taken into consideration at every step of the way, and designing something that they can actually use and benefit from. So we have a high school and middle school version here that ASU kind of oversees. We are the hub. And we really do have students working on projects in partnership with local nonprofits and perhaps a unit or department within their school to identify challenges and develop engineering solutions. We just wrapped up their showcase last night. So we had in total 62 teams of students present their projects. This particular picture is of a group of students who did a project for an organization called Project Cure. Project Cure collects and disseminates medical equipment to communities in need. So we see a huge array of nonprofits, and what we find is that not only are they mimicking the work of real engineers, but they're understanding and learning, again, that idea of awareness, right, of what engineers do. The engineers really are working to solve societal issues. It really taps into that that need to be helpers and to provide a service in students who may not otherwise realize that engineers are helpers. So it breaks down those stereotypes about who is an engineer and what engineers are, and kind of shows the softer side of engineering and the social relevance of engineering. We really feel like this project is something that really is can have potential for a high impact, as students are really immersed in year-long projects that they are actually delivering. So they're seeing the design process from start to finish.
And I want to mention one thing about EPICS High. Cesar Chavez and Metro Tech High Schools in the Phoenix Union High School District have had a great track record of offering very strong EPICS programs. We've been doing this for 10 years. So these are teachers who've been with us for a long time. And those schools have earned US patents for the work, or the students, not the schools, through the schools' work. The students on specific teams have won US patents for the work that they've done through EPICS, which really shows that first-generation students, underrepresented minorities, are able to innovate and impact society in meaningful ways and make significant change for the community in a positive way. So we're very proud of these efforts. We now have some time for questions and discussion.
Okay, Jennifer, we have a few questions, or whoever wants to take them. So from Alicia, in our district, we have engineering in middle school and high school. At what level do you feel recruitment is most successful?
A very good question. I was talking about this to somebody yesterday, and I've researched both middle and upper elementary rising middle schoolers. Arizona has K-5 schools and K-6 schools, and I've actually studied students who are rising sixth graders and all the way up to their end of middle school and high school. One of the things we've learned is that the earlier you begin to provide opportunities for students to explore engineering, the better you are, because students typically make choices about their career pathway in high school, sometimes using information that what I would consider is ill-informed. That they don't really have a full understanding of the choices that they're making. Sometimes those choices are made, and there's science education research of 25 years that shows that students make choices based on where the cool kids are going or where their boyfriend or girlfriend is going. They're not often made based on what their interest is or how they feel about the education pathways that they're choosing can be useful to them personally and to society. So I would say the earliest place should actually be elementary, and then really for awareness, and then in middle school for strong experiences that will help them want to do those things on their own as co-curricular or extracurricular activities in high school. And I'll let Jennifer speak to this as well.
Yeah, and I would agree with that. You know, the younger the better, and you know, there are ways to. Well, so here's the thing about engineering is that, you know, I like to use the analogy. It's like a black box, right? We know that young people, you know, children may or may not know that engineers exist. And if they do know that engineers exist, they may not know what they do. And this is even true for high school students that we've worked with. You know, teachers, they're in front of all day, every day. They know what a teacher does. They're in front of doctors all the time because they seek medical treatment. They know what nurses do. But how often do kids get to interact with engineers or see what engineers do? Not very often at all. So opportunities to show kids what an engineer is and what an engineer does should happen, like Dr. Ganesh mentioned, as early as possible. To your specific question about middle school versus high school, we know that girls in particular start making choices about whether or not they're going to pursue maths or sciences around middle school, that they're, especially with math, their opinions about themselves and who they are in relation to mathematics changes, oftentimes for the worse at around middle school. You know, in elementary school, we see their confidence level high. Yes, I can do math. I'm good at math. And then at some point in middle school, they decide that they're not good at math anymore.
Yeah.
And so trying to find, individual students at that spot and to support them through that change in mindset and try to curb it, I think is a key component. And so especially with girls, I think we need to do more to work with them in middle school to essentially get the idea through that, maybe you feel like you're not good at math, but maybe that's just because math can be hard. Doesn't mean you're not good at it. And it's not a question of good at or not good at. It's a question of how hard are you willing to work at it? How much effort can you put through it? So rather than kind of placing a judgment on mathematics, good or bad, maybe, instead changing the way we talk about it and saying, wow, you were such a hard worker. You are a math warrior. I love how you tackled that and you persisted through that problem. I really love the strategy you used to attack that problem. Maybe you didn't get the right answer, but you know what? That's a really good strategy. So, changing the way we talk about math as opposed to we are good or bad at it, to, what are the strategies we're using to attack math, and how hard are we at working at math?
And I would say everything Jen said about math is true for science as well. And it's not only true for women, it's true for all races and ethnicities, but it's particularly important for underrepresented minorities to also have positive experiences. There's a lot of stereotype threat in society about, oh, you're not going to be good at this because you're a girl. And we have to change that mindset. And there's also this perception that if you're not good at something, that means you struggle at something. Maybe that's not something that you should pursue. If it comes too easy for you, there's a serious problem there. That means you're not putting any effort into it. So we have to change our conversations around effort. In fact, I tell my freshman undergraduate students that in my introduction to engineering class, effort is what's going to get rewarded. And that sort of shocks a lot of students because nobody's ever told them that. They think that they can just do well in the quizzes and exams and their project and they can do it. I said, no, I want you to show me that you can do engineering in these ways. And there are mini projects and a big 10-week project over the 15 weeks that they are in class. And they have to show and demonstrate. There are industry partners who show up to the final presentation and give them feedback. And of course, there's feedback along the way, but it's a big deal, right? Now they actually have to perform engineering. I think we have to change our paradigms about how we help students learn and assess what they know and don't know by giving them opportunities to do things and demonstrate it. Even if they fail, even if their project fails, that doesn't mean they're going to fail the class. That's why I say our effort is what's important. Because I want to know that you've done everything you could to make this work and you can tell me how it worked or why it failed.
And engineers fail all the time. That's part of their job. Their job is to fail and to iterate and to learn from failure. And I think, we need to see math and science in a similar view. It's not, my opinion, it should be less about whether or not you got the right answer and more about how you came to it.
Yes, absolutely. Right on.
So sorry, we need to move on. I think Robin has a lot of great stuff to talk about.
One more question came in.
Okay.
Robin, do you want me to wait till the end or it's up to you?
I think we have time. It's what, 10:45. We have another 45 minutes.
I think it's relevant in the context of the discussion. So let's go ahead with the questions.
Great.
Okay, perfect. So Jill Ford asked, we started at EPICS at UTSA 2 years ago. but haven't yet broadened out to local, middle, and high schools. Any advice you can give on how to get over the hurdle of funding, training, buy-in, etc., from local school districts would be appreciated.
Okay, good question. Jennifer can speak to this for sure, but I'll just tell you, we have tried to raise funding through industry collaborators. We have a very strong development office that's connected to the ASU Foundation, and we have an officer dedicated to the Fulton Schools of Engineering, and he has a group of other officers that work with him who collaborate with us to reach out to individual donors and industry collaborators who write checks. Approximately around $25,000 to $30,000 worth of funding has been used to provide Epic's High teams with materials to deliver their product pretty much every year for the last 4 or 5 years. And we went from, I don't know what, 2-3 schools to 30 schools over the last 5 years. And Jennifer's work has been instrumental in getting that going. So I'll let Jen tell you about how she does this work of getting schools to collaborate with us.
Yeah. So can I ask that you repeat the question? I just want to make sure that I'm addressing it.
Of course. So she said, we just started Epics at UTSA 2 years ago, but haven't yet broadened out to local, middle, and high schools. Any advice you can give on how to get over the hurdle of funding, training, buy-in, etc., from local school districts?
Yeah, so I think that's kind of where, as Ganesh mentioned, we are very fortunate. Our development office does a lot of the legwork in bringing in funding, and then we use that funding to fund schools. So we don't ask anything of our partners. We open the door, and if we have room, we let them in. We use our funding from our industry partners, and sometimes grants. You know, we've had grants in the past as well, to offer training for free for teachers. It is a requirement. You cannot do the program unless you attend training in the summer. And then we send the teachers back out to their schools and say, facilitate this program. And then your students have the opportunity, once you've done the work that we've just trained you to do, to find community partners and develop out your projects. You can write up your teams, your students, not you teachers, but your students can write proposals, submit them to us. We have panels of volunteers who review for us, engineering faculty, students, industry professionals, review those projects, and then we fund them, up to a certain dollar amount. Depending on the year, it's usually maybe $400 or $500 per project. And so we spend upwards of $25,000 a year just on giving funding to schools for projects. And we have found that the best way to do that is actually not to give the money to the schools, because who knows where it goes sometimes, and if it was ever trickled down to the classroom. Instead, they submit a materials list to us, and we order those materials, and they're delivered directly to the schools. Like I said, it's not necessarily asking schools to come up with the money to do the program. We provide that to them. So I think that's kind of unique about what we're able to do. Word of mouth works really well. For a couple of years, we were 1 or 2 schools. And then as those teachers kind of dig in and really get good at the program, they started talking to other teachers. They'd be at a conference or a PD, and, then they just started really coming to us after a while. We also, we host, events that can be quite visual, can be out there for people to see. That's actually one of the best recruitment tools I find, is the projects that students are doing. I know that doesn't help you at square one, but inviting people to come to our showcases and see the projects that students are doing. One of the things that we ask them to submit as part of their project is a video about their project. So we send those out and we post those. Those are a really great marketing tool as well. But I think if you're looking to start out and get schools invested, K-12 schools invested and interested, I think my advice would be figure out a way to make it as low cost as possible. and figure out a way to identify teachers who have the right mindset. There's a certain flavor of teacher that excels in Epics High, and there's a certain flavor of teacher that just can't wrap their head around it. So I would say seek out teachers who are already doing something like PBL, project-based learning, in their classroom. They are already in that mindset that, you know what, the students drive the project and I'm just the facilitator, and I'm okay taking a back seat. I'm not going to multitask. They own that project. I'm going to help them. I'm going to support them. And that tends to go a long way. We also provide current EPIC students at ASU as mentors. So, you know, they actually are deployed and they go out to these schools and they work with students. So, I mean, if they, you know, those are some, I guess, thoughts on how you might, you know, get some partners to get started.
Yeah.
Okay, we have 3 more questions that came in. Richard asked, do you have any suggestions as to how to get non-math, non-science teachers involved in this type of program?
Very good question. In fact, that's an effort that we currently have here, right? So a lot of, not all of our 30 schools have teachers who are only math and science or engineering teachers. Some of them are actually business entrepreneurship teachers who get involved in offering EPICS. Jen, I don't know how that came about, right? It's because they are offering that career and technical education class, and they have a final project that students need to work on. And once they hear about EPICS, they're thinking, why can't I have EPICS become my class's final project? So they work on it throughout the year, and therefore they have a fairly impactful project at the end.
Yeah. And I would say too, like, the thing that we, again, back to the idea of the you know, a certain flavor of teacher, a teacher who does projects in their classroom or is interested in doing projects in their classroom will do well no matter what their subject area is. They have to be willing, though. Here's where the conflict, I think, comes in is even some of our really successful EPICS teachers still struggle with this. And that is, if I don't understand the technology that they're trying to work with, they can't do that project. And I would say that's not true at all. You don't have to have a firm grasp on what the students are doing in order for the students to do that project. All you need to do is say, wow, that's really cool. I have no idea what that is, but let me help you find some resources so that you can go about driving that learning on your own. I'm going to let you surpass me in this area. And I think if the teacher doesn't have to be a science teacher, they don't have to be a math teacher, they have to be willing to let the students take the reins and control whatever learning path that project is going to take them on.
That requires a teacher who is willing to say, you're going to help me learn this as well.
Yeah, yeah.
Okay, Joe asked, how many students are in the EPICS classrooms? Most of my classes are 20 to 30 students, and I've tried community projects before, but had transportation and communication issues. How successful are large student body projects?
Yeah, and I would say that's about the average class size, 20, 25 students. We do have some schools where they've got like multiple teachers running EPICS concurrently with 20, 25 students in each classroom. So they've got like 75, 80 students doing EPICS at their school. I think it really is up to the teacher to decide the number of teams you can handle in your classroom. And, you know, determining, you know, if you want to let them, you know, if you think you can manage teams of 2 in a classroom of 25, God bless you. That's a lot of teams. But I would say in a class of 25, they might have 5 or 6 teams total that they are managing or you know, facilitating at any one moment. And that seems to be the sweet spot.
And the transportation is not really a big issue because the students are not transported to a site where they have to work on the project. The project is usually built on the school campus, in a classroom or in a lab space or whatever is available at the school. They do have to interact with the nonprofit client. That is often done virtually or sometimes in person, if you want to have the students go experience a physical place, but that's occasional. That's not on a regular basis, not every week or every day. So you might do that 2 or 3 times over the course of a year rather than doing it every single day.
Yeah, and if transportation is an issue, you really want them interacting with the space where they're, creating their project. Encourage them to seek out a project on campus.
Yeah.
Okay, you already answered the third question that I was waiting on. So thank you, Robin. We're going to hand it over to you now.
Yes, just 1 minute because I have to show a video now. So Robin is going to help us focus on what are the strategies to enhance persistence once students enter engineering. And this is particularly important for first-generation students, women, and underrepresented minorities. This is a class that I taught to the first group of first-generation scholars that I created a special class for, and Robin will give you more information about that. Our theoretical framework here is to foster students' engineering identity. So before we get into this, I've mentioned engineering identity before, but I wanted to just be clear about what we mean by this. It's a professional role identity that students develop during their experiences as an engineering student or as a K-12 student doing engineering, as a member of an engineering community of practice, where students meet with other students like them, with near peers, professionals and alumni, especially in our case, because we press into service a lot of our alumni to help interact with students, to learn more about the degree and the profession. What is the engineering degree like? What is the profession like? What is the industry like? And most important is to learn by doing. So this engineering identity, we believe, is key in helping students navigate their potential pathways into engineering, and once they're in it, to stay in it. So we're going to watch a video. It's going to go for around 4 minutes. Hopefully it will play well, and you won't have any issues with bandwidth. So let's see if this works well. I'm going to stop sharing the screen and go to the video now. And after that, we'll hand it over to Robin. Okay, just a minute. Get the video on.
What interested me in this competition was the opportunity to do something new that I hadn't done before.
I've never really done robotics or anything similar to this before. I wanted to compete in this competition because it seemed like a really good opportunity to just build my skills. I'm a chemical engineer, so personally, I've never really had experience with coding.
The mission of this competition is to build a prototype for a robot that can deliver food around the ASU campus.
So far, our robot is somewhat functional. We are continuing to add different sensors to help avoid obstacles like pedestrians and skateboarders and those kinds of things, make sure it doesn't run into anything.
What I do in my team is that I am helping design the improved product. I am using SolidWorks, the program, to make a 3D model of it, of what we are envisioning. So it's easier for the presentation, so we can actually show all the dimensions and what we want to do.
I had never worked with these kind of circuits and soldering and wiring in such an intricate manner. So I felt like combining my existing software knowledge with this kind of broader hardware application, that would be a really, unique opportunity for me to grow my skills. Not only that, but also learn more about the entrepreneurial mindset and figure out, what exactly does it take to become a successful engineer in the world.
I have never soldered before this program. So my first time was a couple days ago. I actually burned myself, but I really enjoyed it. I don't know if that's what most people would say, but it's very fun to like get a perfect cone.
Talking to investors, that was really cool. Getting to know the business aspect of it was really interesting because I don't have any experience with that. So I thought that was really interesting. The biggest thing I learned was all the regulations that we have to get control of and all the people that we have to make connections with. There's a lot that goes into making a product like this that I didn't realize there was.
From investors, we learned that safety is priority, only because if there are a lot of people on the same sidewalk as the robot, then there's a lot of chances for accidents, and even a single accident will be not only negatively affecting the human, but also be really detrimental to the reputation of our company.
I learned from speaking with the investors that not only should I ask the questions I have in mind, but also ask for their input, because there are always going to be answers that I haven't anticipated.
My biggest takeaways was that we need to stay focused on the results of our product, helping our customers who are going to be benefiting from these products on an everyday basis.
Our winner is King Foodette.
I think what put us ahead of other groups is that we were able to do everything that the customer and the people we interviewed wanted. We took notes, really precise notes, and made our design based around that.
I learned that it had to be a lot more concise than I thought it was going to be, and you just have to pack a lot of information in as little time as you can. The benefit is just getting experience, seeing what the design process is like.
Competing with kids my age is like something that helps us gauge like where we are as people. So it's a lot of give and take, and all of these have helped me just become a lot better building who I am as an engineer.
Give me just a minute. I'm going to switch back to the presentation now. I hope that video worked out well and you were able to see the video. It wasn't blurry, and I saw some notes come in. Yes, we will make the video available publicly. It is already on Vimeo that anybody can access, and we will post it on our Includes website as well. And anyone who wants to contact us can learn more about how we pull this together. Robin's going to share with you how this was done. And this is primarily Robin's brainchild, who's had a long history of working with industry collaborators to offer such rich experiences. She created something called Fuel, Fulton Undergraduate Engineering Leadership Programs in the summer. And that was sort of the origin for this first boot camp we offered in 2019. So Robin, it's all yours.
Thank you, Dr. Ganesh. So, you know, normally when students think about a career center, they just think about, oh, okay, that's what I think about as I'm getting ready to transfer into my professional roles. And what's really important, and what goes back to the title of this, is we want students thinking about how to become engineers, technical professionals from day one, before you even set foot on campus at ASU. There's a lot of programs that our engineering students experience before they come on campus and in their first semester that are out of the scope of this particular presentation. But the main idea is that we want students connecting with others like them, again, building their interest, their awareness, their interest, their enjoyment, and getting very hands-on to start building their identity as an engineer. So we know that that's a critical part of not just learning cognitively about what engineers do, but let's start experiencing that. And Texas Instruments has really been a great partner in doing that. So next slide. So the Engineering Futures program is, these are the students that you saw. This is a boot camp. I'll get into a little more details about the boot camp. But this is a program, as Dr. Ganesh mentioned, by the National Science Foundation that gave us a structure by which students can go through and experience the things that we know are important to helping students be retained and persist and be successful in engineering. Big part of the program is being attached and connected to your peers for mentoring. Those first years of transition into college and then from college to professional are very critical years that will help people kind of get that solid footing in their identity, in their connection, their sense of belonging. And so peer mentoring is a big part of this program. The other part is that we also mentioned that there are students, sorry. Oh, okay.
Can hear you.
Okay. So was I muted before, or did you hear everything, Jen? Okay, sorry. All right, whatever that was a little weird, but okay. Another part is just knowing that the students have a socioeconomic need and that we worked with NSF and private donors to really try to help provide students with the means to continue. And of course, this is only a portion of what is needed, but it's a very important part of helping students with scholarships to help fill some of those unmet needs. The other parts of the program are lots of career support, helping students to think about how they're developing professionally, imagining their future possible selves, and then getting very hands-on and building lots of different types of technical skills to gain in their confidence and their knowledge of engineering, and then ensuring that there's a deep support network to help students at any point along the journey be successful academically, socially, and with career support. So next slide. Building self-efficacy networks, really critical. And what that means is that we want students, you know, having that knowledge, that confidence, that ability to affect their own personal change, to be able to have that impact and do the things that they really aspire to do. So how do we do that? The structures for doing that, one of those is that we had, as Dr. Ganesh mentioned, an introduction class, an FSC 194 class, where students in a class structure really connected with peers, but they also got very hands-on, learning about just different tech, you know, just different kinds of design projects, or getting hands-on with Arduino boards and sensors and programming and learning how to troubleshoot components. There's also other aspects of bringing in industry mentors and alumni and peers to talk about their experiences, and also making sure that they're connected with university structures of support like peer career coaches and students who can help communicate the tools and strategies not only to be successful academically, but then also how students can become internship ready. Next. So building a sense of belonging and confidence are absolutely critical to retention and persistence in college. How we do this, and as I mentioned, we do that through the class, but also we just make sure that, you know, through these other support structures, that students are through this program meeting alumni, industry professionals, learning firsthand about you know, what engineering is, what engineers do, but then also making sure that, you know, and you will see in a minute a little bit more about how to get hands-on and doing engineering. In these academic success structures and support structures very early on, we have a lot of support from our industry members. Texas Instruments, certainly one of those, Honeywell, Autodesk, Microsoft, and many others. And so, for example, just a few weeks ago, we had Chandler Elliott and Claire Jordan from Texas Instruments help students learn about how to stand out in an interview, how to talk with a company rep or organization, how to prepare, how to get ready to be able to present themselves well and really start to gain that confidence. So when going into those internships and job search phases and doing all of that, that they really have some knowledge and confidence and know people who are basically cheerleaders in their corner, helping them develop those skills and really helping them continue to grow and advance in their roles as engineers. The other part is we learn by doing engineering. I think that's really what we all think of, and that's really where we've had an incredible amount of support from Texas Instrument. The video you saw was of a boot camp, a week-long boot camp is a residential program where through this structure of not only having a core technology, but what's built around that core technology are how do you apply that, right? So we think about entrepreneurial mindsets, students getting really curious, being creative, making these connections, and we give them a societal problem to think about or solve. So in this case, it was using these the TI-RSLK kits, built these little robots, and then students thought about like food delivery. Really interesting is, through COVID, we see these little food delivery devices on campus now. And so students, before all of that, really had some early exposure and really saw the relevance and application of their ideas in very real ways. And so through these boot camps, which are an extension of the program, students are, working with great technology, as we saw here, and you already heard about, about teamwork, about working with their hands, really working with the technology. But then a big part of this is also bringing industry members in who have worked in the field. So they talk about some of the regulations or the issues or the problems that you have to think of from a business perspective, and also from a customer perspective as you're thinking about your design. And so students are not just learning about doing engineering, but they're learning it in the context of the application of that tool and technology in a way that is impactful for society. Additionally, outside of these boot camps, we also have workshops. So Mark Easley, again, did this IoT workshop, and you'll see students at different phases learning about different aspects of working with microcontrollers, sensors, actuators, data acquisition, transmission. So all of those aspects of an IoT system, students are learning very early on, and they're not just, for example, computer science students focusing on the coding part of it. You saw chemical engineering students learning how to code, right? How to run code in a controller, thinking about whole systems, thinking about how all of these elements come together and how all of these different academic perspectives, these cultural perspectives, these customer perspectives are so important into thinking innovatively and transforming the work that's at hand into bringing value to society, and students learned a lot from those programs. Additionally, through these programs, we also have other weekend skill building workshops where students are learning about iterative design process, how to design tools for advanced manufacturing, and continuing outside of the class structure, encouraging students to come together on a regular basis where then as they're building on their own careers, as they're starting to launch, they're coming together independently, to meet, to continue to learn, to grow and develop as they have now taken these core technologies, these core ideas. They've really grown in confidence. We've seen from the assessments how well students responded to these, calling these really transformative experiences that really shaped their engineering identity, that really gave them the confidence in a lot of places to really pursue, not only pursue engineering, but persist when it gets hard, and really seeing a lot of excitement around how they're pursuing their next steps. And in this case, these are great projects that then they put on their resume and they start interviewing, and they really are excited about sharing, all that they've learned in these programs. So we're really thankful to Texas Instruments for being a big part of our program. We've really seen some transformative experiences come from students. And lastly, this is I think we did talk about the key goal here is we are seeing students being successful academically. They are being retained at a very high level. We are we're assessing what students are doing, and we're seeing incredible success with retention. One of our programs, we had 100% retention of our engineers from freshman to sophomore year. So those are really showing some incredible impacts when these programs, when you can bring all these elements together to support students. And it's essential that they thrive in engineering, not just survive. We want students to thrive. And you've seen from all of these examples ways that we give students the opportunity to do that. And when they find this personal and social relevance and it takes hold and there's meaning, we can really see how engineers can then, and students themselves, see how engineers help improve the quality of life for themselves and for society, and they just get excited, and then they launch, they go, and they are very successful moving forward. So I think that brings us to the end of our presentation today, but we want to say thank you very much again to all of our partners in Texas Instruments for hosting us. And also, this is a National Science Foundation grant, and we appreciate the work and the support from National Science Foundation to help us to be able to do this work. So thank you, and I think we have a few minutes left for questions.
While we wait for questions, I'm going to advance to this slide. This has our contact information, email address, our Twitter feeds. Feel free to reach out to us, and we are open for questions.
We had so many in the last run. I think people got so many questions answered, so I didn't see any new ones come in. I'll give everyone just a second in case anything popped in.
I want to make a point about what Robin does. Yes, she collaborates with all these industry collaborators to provide these opportunities for students. We had Intel donate several boards to us so students could actually learn to program and things like that. But the key is that whenever students have these tech experiences, Robin presses into service her team of peer career coaches and staff career coaches who are helping our students understand how to articulate their experience in their resume, how to talk about it in an interview, because oftentimes we can't presume that just having had this experience is enough. We need students to also articulate that in an interview, talk about it in a meaningful way, explaining what skills they learned and why. So there's two aspects to interviewing for an engineering job. One is the technical side, and the other one is the behavioral side. How did you engage with your team members? How did you deal with technical issues that might have cropped up or differences of opinion? How did you overcome those? How did you convince your team members to take a certain pathway? Those things won't come easy. They are not theoretical things, right? We want them to do this from experience. That's where Robin's team makes a big, big, big difference.
Yeah, thank you, Dr. Ganesh. I think one of the surprising things that we never really thought of, and when I hire new staff in, is to think of ourselves, everyone, as potential engineering educators. We're all engineering educators and technical, STEM educators to one degree or another. And embracing that really means having our own sense of curiosity about the problem ahead of us and what we're trying to solve and how we're trying to make those connections and really make that relevance a part of the process, and those reflections, those opportunities to think about what we've learned and then translate that. There's also meaning making from that, and I think that's another part that we saw of the model in terms of relevance. So it's been a pleasure and a lot of exciting work. So I hope that others are able to think about not just the technology, but then how the technology can make a difference.
There are no questions. Ruth, you want to take control back? Or Parisa?
Thank you, Ruth. So I'm just going to wrap up with a few slides for everybody that's still on. Ganesh and Jennifer and Robin talked so much about the partnership that we have with them, and I just want to share with you about what that kind of looks like, if that's something that you're interested in. So first, in regards to meeting and collaboration, when we partner with you, we first really work together to understand what initiatives and pathways you're trying to create in your school or your district. And from there, this is kind of a smattering of our technology and some of the options that we have available that some of these projects implement. And so with the goals in mind that we talked about with you, will help determine what technology can be integrated to best meet those goals. For some, that might be integrating TI Innovator, our microcontroller, TI Innovator Rover, our robotics vehicle. But we work to figure out what's the best technology that's going to be useful for those students in accomplishing those goals. One thing that's really exciting, and this slide isn't even updated because 2 days ago it changed even more, but we are now offering Python on both of our graphing calculator platforms. So on the TI-84 Plus CE, there will be a new version, a new Python version coming out. We just announced it this week. And then on the TI-Nspire CX2, students can code with Python. And so it's a great portable programming platform that seamlessly integrates into your math, science, engineering, and computer science classrooms. And all of that can be done on the physical handheld or in the within the software as well. So we also work to try to create and help build teacher leaders in your district. And one way we do that is through our professional learning and our individualized coaching. So with those goals in mind, again, we help determine what type of support are your teachers going to need to be able to accomplish these goals. For instance, with ASU, we worked on a boot camp for students. So we provided direct PD to students on getting to know the handheld and then using that handheld and leveraging it for success on exams. So again, we can just determine what is going to be the best options for you, but we want to create those teacher leaders in your district so they can then spread the message to others and encourage other people to get involved as well. So since we have people from all over the country, I just want you to know who your ETC is if you're not in Texas, Arizona, or New Mexico. You can find their contact information on our website, but these are the other education technology consultants for the other states. And then I want you to be aware and know about our upcoming TI Talk that will be on June 3rd, which will be about accelerating student engagement through computer science and data science. So we look forward to you joining us for that event as well. We appreciate you guys being here with us today. And one thing to keep in mind is you will receive all these slides and there will be a link to the video recording on our website if there was anything you missed. In the slides, of course, you'll get Ganesh, Jennifer, and Robin's contact information. So please don't hesitate to reach out. Ganesh put the bootcamp video link in the chat to everybody. So if you want a chance to view that again, please do. And then are there any further questions or comments before we wrap up today? I appreciate everybody's questions. You guys gave such wonderful discourse to this. And I think some great collaboration took place. So thank you for adding those comments in. And we just want to thank Robin and Jennifer and Ganesh for all the time and energy they put into sharing these initiatives and the work they've done. Thank you guys so much.
Thank you. This was really fun.
Yeah, same here. And Mark and Oscar from TI are on the chat. So, thank you, Mark.
Yes.
Thank you, Oscar, for all the work that you've done with us.
Yes, thank you, Mark. Thank you, everyone. It was a pleasure.